let us do one example basically. Alright, so let us see this example. Use Newton's method to approximate 0 of fx equals to x to the 5 plus x minus 8, and then continue iteration until two successive approximations differ by less than 0.001. You will continue using this technique, okay, this technique, until you get x2 and x3 or x9 and x10, the difference is less than 0.01. Find the 0 to 3 decimal place. So whatever you find, you record that answer to 3 decimal place. And also compare your result using the calculator. Do you know how to find the root of a polynomial using calculator? It is like second, trace, and then root, right? That's what you do. Okay. So let us do this. So first of all, let us check the assumption of the Newton's method. What we need. Fx is continuous. Yes, this function is continuous. Okay, and this is differentiable as well, and fx has x-intercept on AB. We need to make sure that it has a root, real roots or real 0. Okay, how do I do that? I use the intermediate value theorem. How do I do that? Let me find out a number that give you positive value here, and then let me find out another number or value of x that give you negative value. Okay, so what I can say is let's plug in 1 for x. Since we can write f is continuous and differentiable everywhere. You don't have to worry about AB. It is everywhere. Okay. Also, how about f at 1? F at 1 is 1 to the 5 is 1 plus 1 is 2 minus 8 is negative 6. This is negative. And how about f at 2? If you plug in 2, you will get 2 to the 5. 2 to the 5 is 32, right? It is like 2 times 2 times 2 times 2 times 2. So 32 plus 2 is 34 minus 8 is 26. 26. So it is positive. See, at 1 it is negative. At 2 it is positive. So it looks like the graph will be like somewhere like at 1 it is negative 6, right? At 2 it is positive 26. It looks like this, right? So there must be a root. You want to find out that root. You guys understand that? Okay. Now, how do I do that? We use the formula. So what is the formula to find out xn plus 1? This is the Newton's formula. So we use that formula is xn minus f of xn is f of xn. Let's write down that value first. F prime of xn. I wrote the formula. Now I will find out the value of f of xn. What is the f of xn? So it is basically xn. Let me write down xn plus 1 equals to xn minus. Fxn is that value, right? So it is xn to the 5 plus xn minus 8 divided by, what is the derivative of f? It is like 5x to the 4 plus 1, right? But you are replacing by xn. So it will be 5xn to the 4 plus 1. That's what you get, right? Next, what we do is we make a table with n in one column, and the second column is xn, and the third column is xn plus 1, which is basically this formula we got. Okay. Now, what we do is take n equals to 1. Okay. And then when n is 1, this xn becomes x1. So what value of x1 should I pick? It's just a random number I pick. Any value I can pick. But I should pick the one that is close to the root. Okay. So how do I know that it is close to the root? Is we know that at 1 it is negative value. At 2 it is positive value. So the root must be, or the 0 must be between 1 and 2. So pick any number between 1 and 2 work. So what I pick is I picked 1.7 there. So I pick x1 is 1.7. You can pick anything. You can pick 1.1, 1.9, 1.8, 1.5, anything there. But pick close to the root, or close to the root means since we know that the 0 lies between 1 and 2. So I pick 1.7. Now, so when I take n equals to 1, this will become 1 plus 1. So x2 equals to x1 minus x15 plus x1 minus 8. That's what I got, right? Now I plug in the value of x1. Use calculator. I got 1.5153. So this is x2. Now at n equals to 2, I got x2. x2 is pick that value, copy that value, and then plug in n equals to 2, give you x3 equals to x2 minus x2. I'm taking n equals to 2. That's why. Okay, I got this value. Now plug in x2 equals to 1.5153. You get 1.4603, which is x3. Now at n equals to 3, this become x3 is the same value, copy that. And then there you will get x4 because n equals to 3 means x and 3 plus 1, 4 equals to x3 minus that value. Plug in the calculator, I got 1.4560. Continue the same way. So for n equals to 4, x of 4 equals to 1.4560. That's what we got. And plug that into that value, right? x4 minus x4 to the 5 plus x4 minus 8, and then divide by 5x4 to the 4 plus 1. I got 1.4560. Now I stop. Why? Because look at this x values. The x2 was 1.51, right? x3 was 1.46. x3 is 1.45. Look at this. It is getting close to 1.45. You see that? So 1.4560. But when I find out x4, it is 1.4560. The question says that you will stop after the difference between two consecutive values is less than 0.001. But we got exactly the same value up to 4 decimal places. So we are okay to stop. So this is the approximated root for the function. So how I say is the 0 of fx is approximately, this is the approximately 1.4560. Thank you guys.